So far, like in the previous section, previous class, we have done multiple integrals and gradient, divergence, and curl, and all those things, right? And today we are getting into a very important topic, and I'm sure many of you are facing problem in this part. And I'll tell you, I mean, if not all, there are many questions which can be solved in like 2 lines, 3 lines, maybe more than nothing more than that. But you'll have to like have the catch. You'll have to catch it. What are the elements you have to like catch it and solve it in the next 2 lines, right? So we'll be discussing everything today. We'll be discussing line integral, surface integral, volume integral. We'll see the different methods of solving it. And like line integral, there are many questions coming on this topic, and no doubt on surface and volume integral also. And this won't be finished here. I mean, this doesn't finish here, because after this we'll also be moving into, after this, is it connected? What is wrong? Good morning, Kirti. Good morning, Snehal. So I don't see myself live. So is it coming? Tell me yes or no. Am I audible? Is it visible? Is my screen visible to all of you? I don't know what's wrong. Everything seems fine, but I don't know what's, I mean, the screen is not running. So I'll be waiting. I'll wait for a while, because in case I'm saying something and you're not getting in, what's the point? No. Happy Dashera, Lokesh. Happy Dashera. So Kirti, you're not getting me, right? No. So in that case, we should wait for a while. It is not. So is it not visible, or is it not audible? Because how you are answering me then, right? I don't know what is wrong. Let's start recording. That is fine. Net issue of my net issue. Okay, what is wrong? Okay, then we'll have to wait. I don't see any other option. Let us see what can be done. Not visible. So I'm audible, but I'm not visible, right? Okay. Please wait for a while. Let's see what can be done. Stay connected. Don't miss this class. This is very important. And I don't have much options. Let's see. Not visible. Be there. We'll see what can be done. My net issue. Okay, I got your point, but what is it? I mean, fine. In that case, you should like wait for a while. We will have to wait, right? At least I'm audible. So just let's see what can be done. I think. So if at least I'm audible, what I was saying is, this is very important, and important in the sense, first thing, yes, you get too many questions from these topics. Secondly, it is not very clear to many of you, right? So that is why also I'll consider it to be important, right? What you don't get and still comes. Hotspot. Okay, I'm trying. Let's see. Okay. No, I don't think there is any downloading going on. And anyways, if even if there is a download, it won't trouble me. Like it is a high-speed internet, so anything going in background is also fine. Just wait for a while. I'll see what can be done. Okay, there is something wrong with the internet. If my voice is audible to you all, and it is the upload speed. I mean, the download speed is fine. The upload speed is limited. So maybe I should restart the system. I mean, restart the my internet modem and all. Right. So in that case, I think now you are stable. I'm stable now. Is it? Can you see me? Tell me yes or no. No, sir. So I'm audible, but I'm not visible again. Yes, sir. You better restart it. Okay. Okay. In that case, just be there. Give me a minute. Right. Yes. In the sense what? Yes, sir. Everything. What? Like, is it audible and visible both? What is it? Because I cannot see myself streaming. Like I have my YouTube open. Only voice is audible. Okay. Visible, sir. One of you is saying visible. One of you are audible and visible. Okay, so I'm audible and visible both, right? But what is wrong? Like I cannot see my chat. I mean, I can see the chat, but I cannot see the streaming. So what it could be in that case? What is wrong today? It's a very important day today. We have a very important topic to be covered. Restart. Okay, then give me 2 minutes. I'll be restarting my internet, right? Because system is all fine. So am I there? Can you see me? Well, let's say if I'm waving and you can see me. Is it running live? Yeah, it's running live. It's running live, but I'm on a, let's see if it works. I don't know how long this will work, and maybe I'll have to switch to the internet, like another one maybe. So it's clear. Very good. So we are back, right? Okay. Thanks for having that patience with me, and let's start with the topic. Fine. So maybe afterwards I'll switch to the another internet back, and if this is a limited one, of course this is a limited one. So let's see. So what I was saying is this is a very important topic. We are going to discuss line integral, surface integral, volume integral, and also why important, because two things. Yes, they ask you a very so many questions on this. Secondly, many of you are not very clear about it. Maybe you have to imagine the curves, you have to imagine the solid body, you have to imagine the surface, and that is why we sometimes, like, due to this limitations on the imagination, we sometimes get into trouble and we may go wrong. And if you are very clear about it, then it helps you to do it very quickly. Happy Dasera, Kirti and everyone. So we were having few more friends here, and I don't know if we have lost them or are they coming back, because yes, we are live and we are continuing with the class, right? I don't want any interruption or any gap. Fine. So in that case, we will be moving to our subject, right? So we are moving to the subject, and yes, we'll start with the line integral. Before getting into the questions, let's see a basic formula, and we'll see another applications and another forms of this or like formula also, no doubt. So this one, yes. So let's see the formula first, and then we'll see another things. Line integral, that is, let's say, okay, let's say we have a curve. C is for the curve, and we have to find the line integral f dot dr, like that, right? So there are possibilities that f will have, like, of course it might be having three of the components f1, f2 and f3 being a vector quantity, and similarly r will also have the components x, y, z, and it may be in terms of another factors. So the formula, general formula, is this one is for the scalar and this is for the vector. So f of x, y and z, possibility that x, y and z are the like functions of another variable or parameter t, and then r dash t into dt. The general formula is this one, but if r is also a function of another term, then this dr can be given as, I'm writing it here, dr can be given as, let's say, dt and dt. So this becomes r dash t into dt, and that is what we have here, right? This is what we have here. So we'll get into like understanding this, but let's see. Let's start with the first question, and we'll see what can be done. Yes, fine. So let's start with the first one, and let's see what is it. It says that there is a you have to find the integral of this function, right? So here, if you see it correctly, what is happening here? Let's understand this one clearly and in a more detailed form, and then maybe we'll be switching to like next questions. We'll be trying it in a sort of way, right? So let's say you have f as f1 as I cap I component, f2 as j component, and f3 as k component. Very well. Also, for a curve, let's say we have a curve, we'll have x, y, z components, right? So I'm writing whatever it may be. The curves will have like equations of the, like, there will be dependency or maybe dependency on another variable or on each other. There can be possibility like y is equal to x square. So y depends on x. Otherwise, like in the previous case we said x, y and z both are all these are functions of t, so there are all possibilities. So the position vector, what is position vector? For a curve at any point, the point anywhere on this curve is the position vector, like if you connect it from the origin. So let's say this is x and this is y and this is z. So the point is this position vector, small r, sometimes capital R it can be, will have its x component, its one second, its y component, I mean j component, and then its k component. Right? What are these? These are x, y, and z. Fine. Now this x, y, and z may be depending on each other, may be depending on some other variable. Anything is possible. Now, in our case, what is it written? It is written that the path is something from A to B, and it is a straight line. Fine. So if it is a straight line, we can find a linear relationship between all these parameters, or we can make all these parameters x, y, z being dependent on some fourth variable in a linear way. Right? How we can do it? Let's see this. How can we do this? We can do this by checking the points or coordinates of A and B. So we have done this parameterization in our recorded classes also, and it must be available on the notes also, but still I'm giving a very brief. I'm not giving a detailed manner of explanation here. So it is 0, 2 and 1. This is 4, 1 and minus 1. So let's start with function or the variable x. So let's see x. What is the general form? Will be del x times of t plus x naught. What is del x? Del x is the change, like b minus a, the components of b minus a of the x, y and z, like that. And x naught is the point of a, that x component. So if you see, it is going to be, I'm writing it here, it is going to be 4 minus 0. So it is 4t. And what is x naught? X naught is 0. So I'm writing it plus 0. Clear? Similarly, y can be written as del y t plus y naught, or maybe I'm writing it in caps, y naught. So what is del y? This one is 1, the y component, and this is 2. So 1 minus 2, this will be minus 1. So minus 1 times of t and plus y naught. So this is y naught, the initial point. So that is 2. Similarly, z, del z t plus z naught. So what is del z? Minus 1 minus of 1. So this is minus 2 times of t. Now you are very clear. I mean, anyways, it is not very big thing. And z naught is 1. So now we have x, y, z in terms of t. Now what about the limits of t? What is the range of this t? So this range of t, I am writing it here. It will have a range of 0 to 1. Now if you want to make sure of it, you can just start putting 0 and 1 both, so that you'll get a linear relation. Like if you put t equal to 0 in all these three cases, what you'll get? You'll get x to be 0, y to be 2 and z to be 1. That is what you want. And if you put t equal to 1, you'll get x to be 4, y to be 1 and z to be minus 1, right? So that is what you are getting at. So now again the next point is this dr. Now that we have written r, this dr is going to be dx I component plus dy j component and dz k component, right? Let's j component. So in that case, if you see, maybe I can write it here. If you see this one as x, let's say this is x, of course this is x, then 4 dt should be equal to dx. Similarly, if this is y, then minus dt should be equal to dy, and if this one is equal to z, minus 2 dt should be equal to dz. Correct? All these are right. I mean, I'm writing it in a small space just to like, of course it is understood what will be dy and dt, but still. So now putting it back, so this in terms of dt, if we are writing, dr is going to be like dx is 4 dt, so 4 dt I cap, dy is minus dt, so minus dt j cap, and dz is minus 2 dt, so minus 2 dt k cap. Clear? And this can be written like, if we are taking dt outside, it can be written as 4y minus j minus 2k times of dt. No problem here. So what we have done is we are writing dr in terms of dt now. So that is the part of parameterization only. So far we are parameterizing the components x, y, z because we have a curve. So if you have a curve, we may be having a relationship between the components x, y, z components like that. So that is why we are doing this. Now after this, coming back to our formula or the evaluation part, we want f dot dr, right? And I'm saying now this is going to be f dot r dash in terms of t and then t dt. So the limits of t is t equal to 0 to t equal to 1. Now this is the part of substitution. What are we going to substitute? We are going to substitute x, y and z, which we have found in terms of t. So what was our, let me refer question. Yes, so the equation was, I mean, I'll have to slide up again every time. So let me refer this. So it is 2z. So this 2z can be written as 2 times of, what is z? Minus 2. You can slide up and check this. Minus 2 plus 1, like you cannot do it live, you can do it afterwards. So minus 2t plus 1, and then this is 2y. So instead of like dx, I can write, if you want, instead of dx, although I don't need this one now because the dot product has already been done. So I'm writing dt. What is dt? dt is 4 dt. dx is 4 dt. So the z component, or I'll say k component, that is 2x. So 2x is going to be plus 2 times of x. What is x? 4t, and dz. What is dz? Minus 2 dt. This is what you have, and the limits for t is t equal to 0 to 1. Now you have a simple calculations to be done. I mean integration and then resolving and then doing the integration part. So let's see what are we getting here. Let's talk about the t component, because this is 4t. Let me use this one. Yes, so you'll get t as minus 4t. I'm writing it minus 4t. The another one is and into 4. So let's write into 4 also. Minus 2t and into minus t. Minus 1 I'll say. 2 into 4, 8t and into minus 2. Right? So I'm taking all the t components outside. So it is going to be, this one is minus 16t. This is plus 2t, and this one is minus 16t. The first one. The third next will be constant part. So this will give you 2, and this will give you 2 into 4 equal to 8. This will give you 2 into 2 4, and this minus will give you minus 4, and there is no constant in the second part. So it is going to be 8 minus 4 as a constant, and of course all of this is having dt. I'm taking dt outside, so 0 to 1. So we have minus, I'm writing it here, this is going to be minus 30t, and this is going to be plus 4, which you have to integrate. So I'm avoiding some of the steps now, and you can do this integration very easily in terms of dt. So what do you get to get? Minus 30t, so it is going to be minus 50t square plus 4t, and the limits for t is t equal to 0 to 1. So what is it? For 0 all the components are going to be 0. For 1 it is going to be minus 15 and plus 4, which is minus 11. So minus 11 is the answer. So are you getting it? I have done it in a, explain it in a detailed manner, and then of course it will take some time. But afterwards we'll be skipping some of the steps, and it will be very easier, like you'll get it what you are going to do in the next two steps also, right? So overall what we did, the f dot dr was already given. So what is dr here? Dr is dxi dyj and dzk was already done here, which you can see here, this part. Secondly, there was a curve. So for curve, there will be some relation between the components. They might be interdependent or they might be depending on something else. And then parameterization, so that you can put all these x, y, z in terms of t and dx, dy, dz in terms of t. Then you have to substitute all this, and after that you'll get the like my simple calculation will be there, and that you can do, right? So this is how you're going to do it. Now let's move to the next question then. Try this one. This is also a straight line. W 2016. Try this one. Okay, fine. So fine. Now, so in this case, there is a second question. Now what we can do is we can clearly see that there's a point B option. Okay, let me see. Question number 2. Yes, B is the right answer. You can clearly see that in this case, the all the components are going to be like x is going to be t, y is going to be t, z is going to be t. So of course, dx is going to be dt, dy is going to be dt, and dz is also going to be dt. Right? So in this case, it is going to be very simple. All you have to do is, I'm doing it in next one line. T equal to 0 to 1. Instead of x and y, everything x, y, z, you can put directly t. So 2t into t square. So 2t cube. Dx is going to be dt, dy is going to be dt, dz is going to be dt. So we can take it outside. 2x square y. So it is going to be 2t cube again, and plus 1 in terms of dt. Now do you see that you can solve it in next one line? So it is going to be 4t cube, that will be t to the power 4 plus 1 integration t, integration from 0 to 1, right? So for the case of 0 it is going to be 0, for the case of 1 it is going to be 1 plus 1, which is 2. So that's it, done. Now do you see that you actually did it in 2 lines only, right? So that is done. Let's see the next one. And it is not always required that you are solving it in this manner. There are other manners also, but we'll see. Let us see the question number 3 now. I'm again saying you don't have to solve all the questions in the same method. Why I'm saying this? You'll see it here. Question number 3. So there are other properties we have discussed about this line integration in our recorded classes, also in our notes also. You can refer it. Of course, you can check the link for all, whichever branch you are belonging. You can check the link and you can see that list, and you can check the theory part also. Now, in this case, the function f is given as x square I plus y square j, right? Generally in this form of equation, what is this form of equation? This form of equation is like when you have I, for the I component you have only factor of x, for y you have only factor of y, and like that. In such cases you will observe that there will be something which we are coming up with. So in this case, if you see, I am telling you that there is a function, possibly there is a function f, for which if you find gradient you may get this f, right? What I'm saying is there is a scalar function small f, for which if you find the gradient you may find a vector, which vector is given as this one, right? In that case, this small f, the scalar part, is known as potential function. Potential function. And also in such cases your vector field capital F is found to be conservative. You can also say it is found to be path independent. And of course there are other terms also which can be used for this. Now how do we find that this is a function which can have a potential function? So what I am doing is, of course you know the formula of how to find the gradient. Gradient f is going to be df by dx for I, and df by dy for j, and df by dz for k. Fine. So that means if you relate this one as capital F, I am saying this I component should be equal to df by dx, and this j component should be equal to dy by df by dz. Of course there is no k component here, right? So in that case what we are going to do is, if you integrate this, right, what is it? Df by dx is equal to x square. On integrating, what we are going to get is f is equal to x square. Generally when you have a function of one variable you say x square plus c, but when you have a function of 2-3 variables, integrating in terms of x means there can be a function in terms of y, or possibly in terms of z, and possibly a constant which can be considered to be any function of y and z. Similarly, this df by dy, which is given as y square, on integrating will give you f is equal to, so this integration I have done is, I didn't integrate it, right? One second, I didn't integrate it. So this integration is going to be x cube by 3. Similarly, in this case f is going to be y cube by 3 plus some function of x plus some function of y, right? Why I'm doing all this thing? Because I'm trying to show you that probably this capital F, the vector function, is a gradient of a potential function. And what will that help you with? We'll see that. So if you compare this f found from the integration in terms of x and the f which we have found in terms of integration in terms of y, you can see some of the components which can be compared. Like the function of x is actually this x cube by 3, and this function of y is actually nothing but y cube by 3. So that means overall this f is actually x cube by 3 plus y cube by 3. right? Of course you got it. So in that case, if this function is having a potential function, the integration, the line integral of this function can be given as the line integration f dot dr. Let's say it was from a point P to Q, can be given as f of Q minus f of P. And if you see, in this case, this is your point P and this is your point Q. And of course, you have also found the function f. So it is going to be x cube by 3 plus y cube by 3 from 0, 0 to 1, 1. Which means if you put 1, 1, it is going to be 1 by 3 plus 1 by 3. And if you put 0, it is going to be 0. So this is final answer is 2 by 3. So sometimes you have to observe that if it is a potential function, it is having a potential function, then you should directly put the values, the limits, and you don't have to care of the integration. You don't have to also care of the path given, right? It becomes path independent. Let's see the next question then. Check this one. It says this is a function f, the value of the integration of the gradient. So do you see that they have given you a scalar function and they want you to find the line integral of a gradient. So no doubt now you don't have to find the gradient, you already have a potential function, so why to find the gradient and do the integration? Instead of that, what you can do is you can directly check the starting point and the end point. So let's say this is A, this is B, this is C, and this is D. So this line integral grade f dot dr can directly be given as f of D minus f of A. Why? Because this f is a scalar function, the potential function. So you don't have to find the gradient and then do the line integration, right? It is going to be conservative field, it is going to be path independent, it can be directly found at the endpoints. So that means, can you find the values? 2x cube plus 3y square plus 4z at the points. At point D it is 2, 6 and minus 1, and at point minus 3 and minus 3 and 2, whatever it is. So just put the values now. Put this D and put this A. That's it. Nothing else. You don't have to do anything. This is a 2 marks question from 2019. But if you see, if you put 2, 6 and minus 1, you will get 120 minus, when you put A as minus 3 and 2, you will get minus 19. Of course, you can do the calculation. And this will give you 139. So this is going to give you 139. That will be the answer. Of course, there are other methods of solving this. What do you do in another way if you are solving it in another way? Let's see A to B. If you see A to B, like if you have 4 paths, you have to integrate one by one, right? And it says that the segment joining this A, B, then B to C, then C to D. That is what you have to do. So if you see the points A and B, this minus 3 and minus 2 is changing, whereas minus 3 is same, 2 and 2 is same. That means y is not changing from A to B, z is also not changing from A to B. So in that case, dy will become 0, dz will also become 0. And what is the variance of x? X varies from minus 3 to 2. So in that case, you can write dr to be equal to directly dxi component, right? And possibly you'll have to find the gradient. So what is going to be the gradient here? Should I write it here? Let's say I'm writing it as capital F. This is going to be 6x square Of course, you know how to find the gradient. We have done it in the previous lecture. And then 3y square will be 36yz and 4k. Right? So in that case, what you'll have to do? You'll have to do the dot product of f and dx, like only I components. Similarly, when you're moving from B to A, B to C, if you see from B to C, that is 2 comma minus 3 comma 2 and 2 comma 6 comma 2. If you see this 2, that is x component, is not changing, this z, that is 2 and 2, is not changing, only this y component is changing, which means dx is equal to 0 in this case, dz is also equal to 0, and in that case dr will become dy j component, right? So that means what you can do is, now the dot product will be only for the j component because I and k components are 0. Similarly, c to d. So give me a second, I'll write and then I'll slide it up. 2, 6 and 2, 2, 6 and minus 1. So in this case, if you see, this x component is not changing, y component is also not changing, only this z component is changing. So that means dx will be 0, dy will also be 0, and dz will be there. So dr will become only dz k component. So in this case, you'll have to do the dot product only for k component. And so that you'll have 3 of the integration, that is, I'm telling you here. So what you are going to do is, this I is going to be integration of f dot dr, let's say from A to B, plus f dot dr from B to C, and then f dot dr from C to D. That is it. So of course now you know that at this point it is only dx, this is only dx, this is only dy, and this is only dz. So do the dot product and find the integration. That's it. I'm not doing it. Anyways, we have solved it in a better way and you know how to solve in this manner. I have explained you everything here. So let's move to the next question. There's nothing in this question again. It is very simple. That same as your second question. Second question was there, right? So it is very simple. It is moving from 0, 0, 0 to 1, 1, 1. You can do it. If you want the answer, I can give you the answer. It is going to be 3. It is a similar question, so I am dropping it. Fine. Let's move to the next one. So now in this case we have a curve. So let's try a curve question. Check this. Fine. There was something wrong, so I was just fixing it. Fine. So let's see in this case. The parameters are already given. X, Y, Z parameters are already given. This is X parameter, this is Y parameter, and this is Z parameter. So from this only, I am writing here dx will be equal to dt, dy will be equal to 2t dt, and dz will be equal to dt again. Fine. Also, this is I, f1, f2 and f3 given. So if you want, you can substitute this. Of course, we will have to substitute this. So just see what we can do. Or is there anything better we can do about it? Give me a second. No, you'll have to directly solve it. So 5xz. So let's start putting it. Fine. Shall we? Or you want me to like elaborate it? So this I is going to be, let's see what is the dot product. 5xz I cap plus 3x square plus 2y j cap plus x square z, one second, k cap. Yes, and I'm writing it here like instead of dr I'm writing it dt I cap plus 2t dt j cap and hi learn and earn, wow, plus z. So instead of z I am going to write dt k cap. Fine. So let's substitute all this x, y, z in terms of t and t square and like that. What you'll have is, of course, this t you can see clearly moving from 0 to 1. So I'm writing the parameters also now and the limits also. So t equal to 0 to 1. This is t equal to 0. 5xz. I'll write it here once and then we'll skip one step. So 5xz. So x is also t, z is also t. So this is 5t square. Similarly, x square is going to be 3t square and 2y will be 2t square. So that is going to be 5t square. Not writing it here, we'll write in the next step. X square z. So x square z is going to be t square into t. So that is going to be t cube. Fine. So let's put it now. And let's do the dot product also. Why? Because I have already written this part here. So you can like dot product I to I, j to j and k to k. So I component has dt only. So this is going to be 5t square. J component has 2t dt. So you'll have to multiply this with 2t. So this is 5t square into 2t will become 10t cube. Fine. And the third component, which is k component, simply dt. So it is plus t cube and overall dt. That's it. That is all you have to do. So do you see? This is simply 5t square. This becomes 11t cube and the integration is going to be, writing the integration directly, 5t square will have 5t cube by 3 plus 11t to the power 4 by 4 and the limits are 0 to 1. So for 0 all of it is going to be 0. For 1 it is going to be 5 by 3 plus 11 by 4. This is going to be 12, 15, 4, 20 and 33. So 20 and 33, 53. And approximately it is going to be 4.4167 and that is what the value is. So do you see? Now you know what is parameterization, what is changing this dx, dy, dt in dz in terms of another variable, and then the simple dot product and then dot product and then integration. So this is about your line integration. Let's see the next question. It is a good one. It is a good one. Question number 7. Let's see. Let's see what are all different things we can do here. Possibly. Okay. Let me make some space. Fine. Let's see this question. So it says there is a scalar potential psi and then there is a gradient psi which is given as this. Consider the line integral or integral simply the gradient dot dr on the curve this one where the parameters are given like this. Do you notice the first line? It is saying there is a scalar potential for which you have a gradient. So of course, if you have a gradient, you can find the potential function also. And how do you do this? You integrate the I component in terms of x, integrate the j component in terms of y, and integrate the k component in terms of z. So should I write it? Let's say I'm writing it as f. So this f is yz I component plus xz k component and j component, one second, j and k. So this is your f1 component, f2 and f3. So you have to integrate f1 in terms of dx, f2 in terms of dy and f3 in terms of dz. I'm skipping some of the overdoing of calculations, right? So in terms of dx, if you integrate, you'll get x, y, z plus function of y plus function of z. Similarly, if you integrate in terms of y, you will get again x, y, z plus some function of x and some function of z. And third time, when you integrate in terms of z, you will get x, y, z again plus a function of x and plus a function of y. So do you see the similarity? Do you have any function of only x when you're integrating in terms of x? No, like only term of x, like x square or x or x, sine x, anything like that. You don't have anything. So if you don't have anything like that, this f of x and this f of x is going to be 0. Similarly, when you are integrating in terms of y, do you have any term of only y, like y square, y cube, 4y square, anything like that? No, you don't have anything. So that means f of y is also going to be 0. Similarly, when you're integrating in terms of z, do you have any term of only z? The answer is again no. So that means f of z is going to be 0. So overall, the only thing left is x, y, z in all of the form found by integrating in terms of x, y, and z. That means the scalar function here for the potential function or scalar function, anything, is simply x, y, z. It is x, y, z. Fine. Now, what do you want? You want integration from t equal to 1 to 3, right? And you, of course, you'll have to substitute t by x also. So instead of x, y, z, I'm writing t into t square into 3t square, and the endpoints are for t equal to 1 and t equal to 3. So what is it? 3t to the power of 5. So I'm taking 3 also outside and 5. So 3 to the power of 5 minus 1. Do this. Should I calculate it? The answer is 726. Minor calculation, the answer is 726. So what did you do? You got it that you have it as a scalar function, so you can directly put it for the endpoints. That is all. Yes, that is enough. So let's move to the next question. Of course, you can see what we did. We actually didn't do the line integration. We moved back to the scalar function. Yes, another one. So let's see in this case of a curve. Question number 8. Yes. So far we have seen that if you have a scalar function for a gradient or for a field, you can say it is going to be conservative, you can say it is going to be path independent, and you can say that you can find it by directly putting the endpoints or limits of the endpoint similarly, so simply for the potential function, for the scalar function, right? Small f. So that is one thing. Other than that, also there are other methods also, like finding if the function, the field, vector field is exact. Or what is exact? Exact is nothing. I'm telling you, exact is nothing. What we have read in the previous class was that if the curl of a vector field is 0, we say it is irrotational, 1. Secondly, we also say it is conservative. Irrotational, fine, and conservative. So the point is, what now if you go back and check the I, j and k components of curl, I'm talking about the k component. The k component will be d, let's say p or f1, simply f1 by dy minus d f2 by dx, or maybe otherwise. It will be otherwise, I think. Yes, it will be otherwise, f2. So this is plus and this is minus. That's it. So if in case you are on a plane, which means you are only on xy plane, so there won't be any k component, I mean that z vectors and all those components. So in that case, for the curl, not for like for the curl part, I, j are going to be 0 and only k component will be there, which is this one. And if you can make this component also 0, then you can say that the curl is going to be 0. And if the curl is 0, it is going to be conservative. And that is what you read about the exact functions and all that, all those things. So in this case, this is your f2 and this is your f1. So let me see this. What is df1, or let's write df2 by dx. df2 by dx, yani ki, this is differentiation with respect to dx, and this one is differentiation with respect to dy. So differentiation of f2 in terms of x will be 2y plus 2x, and minus differentiation of f1 in terms of y, so that is also going to be y, so 2y plus 2x. So do you see that these components are same and this result is going to be 0? So anyway, on a plane, you won't have I and j component for a curl. You will only have a component of k for a curl, and that too is 0. That makes the field to be irrotational, or you can say the curl is 0, or you can say it is going to be conservative. And that is what are the conditions for exact functions also. So in that case, what you can say is it is going to be path independent again. I'm trying to solve it in a different manner in this time. And what you will do is, instead of taking this path, right, taking this path, I'm going to go to the same point, right, like starting from this point 3, 0 to 0, 3, but I am changing the path here. I've changed my path as from 3, 0 to 0, 0, and from 0, 0 to 0, 3. Fine. So if you see for the first part, let's say it is C1 and this is C2. Let's try a different method here. So in case of C1, if you see, when you are moving from 3, 0 to 0, 0, do you see there won't be any change in y? So can you say that dy will be 0? Also, what is the value of y at this C1? It is 0. Similarly, for C2, if you see, from 0, 0 to 0, 3, so there won't be any change in the x part. So I'll say dx is going to be 0, and also the value of x is also 0. In this case, x is equal to 0 because we are moving on the y-axis. So that means our integration, I'm writing it here, I, which is c of y square plus 2yx dx plus 2xy, one second, plus x square dy is how much? That is what we have to find. So now, instead of writing it in this manner, I am writing it as integration for C1 plus integration for C2. Fine. Also, for C1 case, dy is 0. So that means we won't have this component. Why? Because dy is 0. We will have only this component, out of which y is equal to 0. So that means y square and 2yx will become 0 for dx, where x is like varying from, I'm writing it here, x is varying from 3 to 0. Just writing it here. Similarly, for C2, what is it? Dx is 0 and x is 0. So when you are integrating this entire thing for curve 2, dx is going to be 0 and x is also going to be 0. So in that case, you will have 0 integration for y, and the limits for y will be from 0 to 3. So anyways, both of it is going to be 0 and ultimate answer is going to be 0. I have spent a little more time and I've tried a different method, no doubt. Fine. So do you see that now that this was path independent, I have changed my path and then I have found the value. But why did I change the path? Just to make you understand. Otherwise, what we could have done, if it is path independent, the value will also be directly can also be calculated on the endpoints directly. So if you see the function you had, I'll do that. I'll continue with that. If you see the vector, I'm writing the vector. Your vector was, if you see the x, I and j components, it was y square plus 2yx as I and 2xy plus x square as j. Check this. You can check this in the question. This first one is f1 and the second one is f2. That's what. So if you see, again, if you want to find the scalar function or the potential function, I'm doing it directly this time. It is going to be like integrate this in terms of x, you'll get xy square and yx square. Similarly, if you integrate this one in terms of y, you will get how much? So in this case, what will you get? In terms of, I'm writing it in terms of dy, in terms of dx. So if you integrate in terms of y, you'll get x y square and then x square y. So of course you are getting the same thing. That means the scalar function for this case is x y square and yx square. And what was the end point? It was from 3, 0 to 0, 3. Put the values and you'll get the answer. Of course, when you put any of it 0, it is going to be 0. Because if any of it, like x or y, anything is 0, it has both the terms here, so it will be 0. So this is the second method which we have already done in the previous question, right? So we have tried to use the path independence here, and that is sometimes required, and that will be of some good and great help. Fine, I hope you are getting it. Let's move to the next question. Yes. I won't be doing the 10th number, it is for you, but I'll be doing 9th number. Thanks to that internet disturbance, we are running late today. Right? Chalo. Chalo Lokesh, do it. Let's see the question number 9 now. Okay, fine. Okay, we'll have to solve this question now. It says there is a circle with the radius 4 by root pi. Fine, then you have to find the line integration. This is the function given. Fine, good. If it is given. In this case, if you try to find if it is exact or if it is a gradient of some scalar function, you will see that it is not. If you're trying to find it, you can try it and you will see it is not. Fine. So it is not. So now, give me a second. Yes. So in this case, you have a circle. So let me draw it, a rough diagram or sketch, anything. It is a bit of like a little shifted, but that is okay. You have to understand this. Circle. So you know about the parameterization of circle. You have seen the notes and you have seen the recorded classes also. If not, you should refer it. And let's say this is the radius. Then the x component can be given as r cos theta and y can be given as r sin theta, where theta will vary from 0 to 2 pi. Of course, r won't vary because we are on a circle, that is, we are on this curve. So in that case, r will be constant, and this constant value is this one, right? We are on the circle. We're not. It's not a disk. It is on the circle. Yes, Lokesh. Chalo, let's have fun then. Okay, let's see this. So in this case, if you see, you have this path. It is on the circle. It is not a disk. Make sure. So that makes this r to be a constant value, which is already given. Theta will vary from 0 to 2 pi. What is 0 to 2 pi? This is 0. This is pi by 2. Okay. This is pi by 2. This is pi. And this is 3 pi by 2. And then this is 2 pi. Right? So this entire circle in the anti-clockwise, which is taken to be in positive sense. Right? The positive sense is anti-clockwise. So now we have this function, we have this curve, everything is good. Now what we can do is, why not to substitute this value? Yes. So in this method we will be directly approaching, because in the previous method we have already seen there can be other methods. So that was good question, I'll say. This is a conventional type of question. That means you'll have to do it in the defined manner only. Fine. So what I'm doing is, let's find dx first. Sorry, dr. So this dr will be dxi plus dyj. If you see this is dx, then can we write dx is equal to, okay, do you see from this x is equal to r cos theta, dx becomes minus r sin theta d theta, and similarly from this part we will get dy is equal to r cos theta d theta, and of course the variation of theta is same. That means this can be written as, let's take r outside if you want. Of course we can do this. I'm taking r outside. Instead of dx I'm writing minus sin theta I cap plus cos theta j cap d theta. So now you can change the dr integration in terms of d theta. Of course we will have to do this dot product also. F of theta into r dash of theta and d theta. Theta varies from 0 to 2 pi. Fine, this is what we have to do now. So let's do it. So what is y? I'm right. It is f. Can we write it here? Yes, of course we can write it. It's all r space, right? So f is going to be y I cap. What is y? Y is r sin theta. So this is r sin theta I cap. What is 2x? So 2x is 2r cos theta. So plus 2r cos theta j cap. Fine. So just writing it again. So now we have to do some calculations and that will be all. But this is a good question again. Of course it has a variety of its own. And I'm not doing the next question. So it is going to be r. Can we take this r again outside? Is it okay? Let me. So I'm taking this r outside, and this is sin theta I component plus 2 cos theta j component into, we have one r here also, that is instead of r, like this is r dash theta, right? So I'm substituting this. So for this r I'm raising the power as r to r square. No problem with that. And now I'm writing it as minus sin theta I cap plus cos theta j cap and d theta. See this? Do the dot product. So the dot product, of course you have this integration from 0 to 2 pi. So this is going to be 0 to 2 pi r square. I'm taking outside. Why I'm taking outside? Because r is constant here. That's what I have already said. So r square. Sin theta into minus sin theta. So it's going to be minus sin square theta. Cos theta into cos theta. It is going to be 2 cos square theta in terms of d theta. So giving you a substitution, sin square theta is 1 minus cos 2 theta by 2, and 2 cos square theta is 1 plus cos 2 theta, right? Which means, continuing it, this is going to be r square 0 to 2 pi fine. So instead of minus sin square theta, we will write it minus of, I'll split it, 1 by 2 minus cos theta and plus 2 times of, oh no need to take 2 outside because we are writing it as 2 cos square theta only. So it is 1 plus cos theta. Integration in terms of d theta. It is not a long question, but yes, it is a very predefined method you will have to use here. So overall, what are the constant? you have constant as 1 by 2, because this is 1, this is minus half, and this minus and minus becomes of course there is 1 by 2 also. So it is plus 3 by 2 cos. Am I missing something? Yes, I'm missing 2. I'm missing 2 here, so it should be 2 theta and 2 theta. So it is 2 theta. Now you have to integrate this function in terms of theta, and that will give you the answer. Can you do this? Yes. Yes, of course we can do this. And there is one r square also. Fine. Yes. So let's do it. Give me a second here. This is, yes. If I am right, r square is there, 1 by 2 is there, 2 pi is there. Let me check the answer. Just give me a second. It is 16. R square is, what is the value of pi? 4 by root pi square into 2 pi into 1 by 2. Cancel 16. Yes, so the answer is 16. Correct. What I'm trying to do it here is, of course I was rechecking it just. See this cos 2 theta. What will be the value of 0? Cos 0. And what will be at the value of 2 pi? Cos 2 pi. So cos 4 pi and cos 0 is going to be same. So this integration for this limit is directly going to be 0. We are not putting it, right? I was just cross checking before. Of course we don't have to cross check, it can be directly done. And for this half part, it is going to be half into theta for the limit 0 to 2 pi with r square. Now I am putting the value of r. The value of r was 4 by root pi. So this is square. So this is going to be half into, so it is going to be 16 by pi into half. The limit for theta is 2 pi to 0. So 2 pi minus 0 will be 2 pi. So what you can do is you can cancel this pi, you can cancel this 2, and ultimate answer is going to be 16. That is the answer, no doubt. That is the answer. So in this case, what we were actually trying to do is parameterization of a circle. That is important because you'll get too many questions here. So previous one we didn't do in terms of the, like this one. This one we didn't do in terms of circle. We did it in another method, like changing the curve or finding that the path was, like field was a conservative path. Now in this case we are substituting r cos theta, r sin theta. We are substituting x and y also, dx dy also, r dash also, substituting for the function also. So everything is done. Yes, so the answer is 16. Yes, Lokesh. Question number 10 is for you. It is not difficult. It can be done. You just make sure that you are putting y is equal to x square. You are not putting x is equal to root y. Right? And I won't tell you that now. I mean, if you have a problem, we can explain that also. So put y is equal to x square. Don't put x is equal to under root of y. You will know a reason. There is a reason. And you will know it sometime. Or maybe you have learnt it in your 11th and 12th also. Let's move to this circle, surface integration. Of course, this is the formula we'll be using. I'm just giving a glance of it. I'm not explaining it. We'll be explaining everything in your question. So this is a glance of your surface integration. Fine. Just for your reference. Let's see this. First question of your surface integration, and we will be of course using substitution method here also, or you can say parameterization. Let's see this. It says surface integration of this function and dx dy is given. So what is the function or what is the space they are talking about? They are talking about a disk. Do you see a difference between a circle and a disk? What is the difference? Let's say this is your disk. Sir, it looks like a circle only. Yes, it looks like a circle only. But it is a plane. It's not a line. It's not a curve, right? It's not a curve. It's a surface, entire surface. So my point here to explain you is when we are talking about disk, it is this entire space inside. Fine. When you are talking about curve, it is only this one. So first of all, let's talk about the parameterization here. Of course, we have done this in our recorded classes also, notes also, everything is available for you. But let's give a glance. So in this case, what is the radius here? It is, this is r square, right? So r is equal to 2, you can say. Or let me write it as capital R. Why capital R? You'll know. Capital R is equal to 2. So this is capital R equal to 2. So in this case, we are writing x is equal to r cos theta, y is equal to r sin theta. And I am saying theta will vary from 0 to 2 pi. You have to recheck or reconfirm anything. I am not going into deep, but I am mentioning everything required here. 2 pi, and the radius will be small r, as I said, vary from 0 to capital R. What is capital R? It is 2. Why I am writing this? Because when you are talking about disk, it is something like this small circle. Let's use another pen, or maybe this one. It is this small circle which will start from this point. That means the radius will be 0 and it will start increasing its radius, and ultimately it will come to this circle, which is, so this all curve, this all circles from with a varying radius from 0 to let's say capital R or 2, right, like this, is actually making what? It is making a disk. So that is why you are mentioning small r, which is varying from 0 to capital R, which is 2. Also, in this case, I'm mentioning it, you have it, and I won't tell you why. You can get into that detail afterwards also. This dA, the surface area element, surface element is given as r dr d theta. It is given as r dr d theta. So that is dx dy here. That is only dx dy here, right? So instead of writing dx dy, you can write this r d theta. And this shaded region is your d, capital D. This d they are talking about. So all we have to do is some calculations now. 1 by 2 pi surface integration. We will put the limits, not now. We'll put the limits. X, what is x? R cos theta plus y, which is r sin theta plus a constant 10, and instead of dx dy I am writing r dr d theta. Now check the limits. The limits are provided here. So theta will vary from, if I am writing dr, so let's write r first, that is okay. Or maybe I will change the limit order of integration. It won't matter. Why it won't matter? Can you check back the previous video and see why it doesn't matter? D theta dr. I'll tell you why. Just a revision. When the limits are independent in sense, if you see the theta is varying from 0 to 2 pi and r is varying from 0 to 2. So all the limits are constant. Theta is not depending on r is not depending on theta. So in that case, you write dr theta or d theta dr is all fine. So I'm writing theta from 0 to 2 pi and r from 0 to 2. Let's avoid some of the calculations. How can we do this? The limit for theta is 0 to 2 pi. Fine. So if you integrate cos theta and put the limits, you'll get 0. If you integrate sin theta and put the limits, you'll get 0. Fine. So you don't have to do this. What about 10? For 10, you will get 10 theta. Put 0 to 2 pi, you will get 10 into 2 pi. Fine. And you have 1 r also here. So I'm skipping one step. That is integration in terms of theta. This is 0. This is 0. This is 10 into 2 pi. So I'm writing, of course it is a constant. So 10 into 2 pi, and 1 2 pi is also there outside, and then integration of r in terms of dr from 0 to 2. I just made it simple. So can we cancel this 2 pi 2 pi? Yes, we can. What about r? So this r will be r square by 2. So 10 into r square by 2 with the limits 0 to 2. So it is going to be 2. So it is going to be 2 into 10, which is 20. That is the answer. Fine. I'm sure, I hope there's no problem. And we are running short of time. Fine. Okay, we'll see if we cannot complete it today, because you might be having your reasoning classes at 1 if I'm right. So we'll see how far and how quick we can do it. So in that case, that's it. The answer is there. So let's move to the next question. Nothing much was to be done here. Let's see on another one interesting question. I hope I finish in next 20-30 minutes. That will be before your reasoning starts. So read question number 2. Question number 2. Yes. So there is a vector given. They are talking about normal, and they want to find the surface integral of the curl. So let's find the curl first. What is the curl here? It is, the component is minus y cube by 3 x cube by 3. You can find the curl yourself also. Z cube by 3. We will talk about the surface, but let's find the curl first. So for the first part, that is I component, in a differentiation of z cube by 3 in terms of y. So there is no y component here, so it is going to be 0 minus differentiation of x cube by 3 in terms of z. So no z component, so 0 minus j. For j, dx differentiation of z cube in terms of x will be 0. Differentiation of minus y cube in terms of z will be 0 plus k times of, writing this one, differentiation of x cube by 3 in terms of x will be x square, and differentiation of minus y cube by 3 in terms of y, so that will be minus y square, and minus of minus y square becomes plus y square. So that means the curl which they want is k, or I'll say x square plus y square k component. Let's say this is our vector field f, because we have to find f n ds, that is the surface integration. Yes, so what is this f? It was given as curl of a vector field, so instead of that I am writing f here, which is the k component with this. Now we are moving into the question. Before that we were just doing what we have already learned in the previous case. Now for surface integration, a third method is used, rarely used. Most of the time your questions will be solved by first two methods we have already discussed in your recorded lectures. You'll get it there. This surface integration of f n ds, let's say for a surface, can be given as f dot n dx dy by n cap k cap for region D. I'll explain everything here. You have to use this formula. When they are talking about S, this S, when they are talking about S, they are talking about a surface of that whatever like surface they are given. When they are talking about D, they are talking about the projection of that surface on the plane. Which plane? In this case, it is xy plane. It can be yz plane also, it can be zy plane also, zx plane also. But in this case, it is dx dy. So they are talking about the projection of that surface on the xy plane. Take your base, whatever, wherever you're sitting, the table, your notebook, take your base as your xy plane. So you have to put your projection on that base, right? Now let's talk about, and what are all these components, we'll see, but let's get into the question now. So this was the formula. So if you see, the surface they are talking about is a hemisphere. They are talking about a hemisphere. Do you have a water bottle with you? You must be having a cap also. If not, just imagine you have half of a ball. Half of a ball. What is it? It is hemisphere. Consider it to be hemisphere. Okay, let's say this is x, this is y, and this is z component. So this is a hemisphere. Why I am drawing the above part of xy plane? Because it is mentioned it is a hemisphere with z greater than equal to 0. So z greater than 0 means the positive z axis, right? Okay, fine. Now there are a few things which you should know, and otherwise you have it in your reference in the sense both the things, your recorded lectures and your notes also. So getting into detail will be like too much. So if you have this surface, what will be, this is the entire surface, the surface of your ball, the half ball, like half ball of yours, that surface is the surface they are talking about. And when you talk about the base, or when you talk about the projection on the xy plane, when you are keeping it, that half ball on your table, that circular region which you will get on your xy plane will be the projection. So I am making the projection separately. Let's say, sorry, let's say this is xy. So this is the projection of your, like you're viewing it from the top. It's a top view of your hemisphere. So it will have a projection on xy plane as a this circle, and of course everything inside counts. So it is a disk, you will say, right? So everything counts in between it. So it is a disk. So this circle. So what are the parameters we'll consider? Of course, you know x is equal to small r cos theta. You know the difference of why I'm writing small r or capital R. So this small r varies from what? The hemisphere is of radius 1. So it is from 0 to 1, and theta varies from 0 to 2 pi. I'm sure you are clear with the limits, right? This circular region on the xy plane, I have done a small mistake, which is writing xy. This is x and this is y. That is also fine. It's not wrong. This is also right. That was also right. It's just the inclination. I have changed it, rotated. So that means we are going to have this r varying from 0 to 1, because it is a circular disk we are talking about. Because it is not only about the curve of that circle, it is about all the points lying inside that circle also. So of course that means it is a circular disk. Fine. And what about the normal? I'm writing it here. Of course you can refer and find it. Normal for the equation, what is the equation of this surface? The equation is for sphere, which is x square plus y square plus z square equal to 1. I mean, talking about a sphere, the normal is going to be, you can find it by finding the gradient also. Of course, you know how to find the gradient, plus zk component. So this is the normal you will have. And if you know anything coming radially outward from the origin will be a normal, right? You know about this. Fine. For a sphere. So that is nothing but the position vector of that function. So this is a normal, and this is also only going to be your normal unit vector. Why I am writing this? Why I am writing this? Because the normal and the unit normal is going to be same, because the mod value, which that also I am writing it here, the mod value, that is x square plus y square plus z square is equal to 1 in this case. If not, you should have written it as like this. I mean, what you should have written like this. I'm writing it here. N in this case, if it is a sphere of some other radius also, the general expression is going to be this: x, y, j and z k, and unit normal is going to be xi plus yj plus zk. You may go wrong sometimes when it is of not unit radius. That is why I am writing it here: x square plus y square plus z square. In this case it is going to be 1, so that is why you can directly write it. Clear? Fine. So this is also done. Now dx dy is fine, and n cap dot k cap is also fine. No, so we know what is n cap. This is only n cap. I'm writing n cap again. N cap is going to be xi plus yj plus zk. Why? Because it is a sphere of unit radius. So in that case, let's get back to our expression of evaluation. Surface integration is going to be, I'm not putting the values now, it is going to be the field. So what was that field? It was z times of x square. Let's check it once. No, it is x square y square. It is x square, z will come after this. So it is x square plus y square times of k dot product with xi plus yj plus zk, and then dx dy by n dot k. So I'm doing one step here. If this is your n, what is n dot k? It will be simply your k component, which is z in this case, right? I dot I, j dot j and k dot k. So if it is n dot k, I and j component have no use. What is the time here? It's 12:35. I think you can manage like 10 minutes more, so that at least we finish this surface integration. Then we'll move to volume integration maybe in the next class. And thanks to the interruption in the internet, that made it difficult. So this k component, now the dot product is for the k component. So k component will be z times of x square plus y square, and dx dy I am writing it like that only, and that n dot k cap, which I have written as here. So this is z cap, z, only z. So that means this z and this z is going to be cancelled. Yes, I know your schedule, you have general aptitude at 1, but you have like 25 minutes left for that class, right? Just give me 5-10 minutes more so that we can finish at least surface integration in this case. So that means we are left with this part. This is simply x square plus y square dx dy. Okay, let's finish this one. Let's finish this question at least. Let's finish this question at least. So now we were talking about a disk, right? And we have already done a question on disk that dA is given as r dr d theta, and we know all the limits also. So instead of that, what we will do is, instead of x square plus y square, what we can write? We can write r square. Yes, because for a circle x square plus y square becomes r square. So I am writing x square plus y square as r square. Why I am not writing capital R? Because it will matter. Yes, let me finish this and then we will wind up. Into r into dr into d theta, and this r varies from, what was the radius, 0 to 1, and what is this theta varies from 0 to 2 pi. So that is all you need. I'm separating it because we have the variables independent and the limits also. So I'm writing it as r cube. So r cube will be r to the power 4 by 4, limits from 0 to 1, into theta from 0 to 2 pi, which is going to be simply 1 by 4 in this case and 2 pi in this case. So this is going to be pi by 2. This is the answer. Let's recap this and then we'll wind up. Right, thanks to the internet's disturbance, and of course I had a plan of taking it for like 90 minutes at least, or maybe, yeah, 90 minutes is already over, so maybe I had a plan of taking 100 minutes, right? But our 10-15 minutes got wasted for that interruption for the internet. Anyways, let's okay, I understand you have next class. Let's finish this honestly and then wind up. Fine. So we had this, that there was a vector given u, then we had to find the curl, and then we had to find the surface integration. So first of all we found the curl of that, which was x square plus y square k component. Now having this k component, we went for the method, this one, si is equal to this, dx dy by n cap k cap. Yes, there is a method like this, and we can have this method for xy plane also, yz plane also, and zx plane also. Everything is fine, but the only difference will be, for instead of n dot k, it will be n dot for yz it will be n dot I and then n dot j, like that sequence in the sequence. So the surface is a hemisphere. This is the hemisphere we have, and this hemisphere we will have a projection on xy plane, and that projection will be a circle or a disk. And secondly, the normal vector for this hemisphere is given as xi, yj and jk component, and thanks to the radius being 1, the normal vector will be only the unit normal vector. Otherwise you saw that it is going to be divided by the radius of that. What is it? Yes, please. Kirti, what is it? I'm not getting any of your message, so let me finish this at least, right? So that is it. You found that n cap also, and now you know what is n cap into k cap. That will be only k component, which is z. This is the z n dot k. Fine. So in that case, all we are left with is the dot product of f and n. What is this? This is f dot n, which is nothing but z into x square plus y square, and then dx dy by n dot k cap. So that is, this one is simply z. So this z and this z gets cancelled. And in the first question only, we have seen that dA is given as r dr d theta. You know the limits for it, right? We have done it on in the previous question only. The limits for r is from 0 to capital R, that is the outer radius, and theta varies from 0 to 2 pi. Just put it and you will get the value. So this is, the answer is going to be pi by 2. Yes, it is a bit of lengthy question, but the point is some of this we have explained it, otherwise it was not required. Like the normal of a hemisphere, normal of a square is known, normal of a sphere and hemisphere is known. What is dx dy in terms of dA as r dr d theta, everything is known, the limits are known. So this is something which will take less time if you start practicing more, right? So let's wind up here, if it is 12:40 now, and we have volume integration left. We have a few more questions from surface integration also. We will be continuing in the next class with volume integration. Okay, fine. So we'll be continuing in the next class. We'll be finishing up with surface integration. We'll be finishing up with volume integration, and then we'll be moving to the theorems. That is Green's theorems, Stokes theorems, and Gauss divergence theorems also. So by the next class, that is what we are trying to plan. And thanks, like whatever went wrong today is okay. So in the next class, we'll be finishing up calculus here. And yes, there are a few things which can be managed by you also, and then we'll be moving to the probability from the next class, right? Okay, then have a happy Sunday. I hope you enjoyed, you learned something, you found it better. I mean, yes, there is a lot of imagination required for the curve, for the surface, for the volume, for the body, everything. And yes, they need parameterization, very important. So what is important here is, when you are trying to solve everything related to this topic, you have to do one thing, that is know the parameters. Know the parameters. I have provided you an entire list of all the parameters for cone, cylinder, sphere, circle, line, everything. What if you need it for surface? What if you need it for a body or 3D? What is the normal? What is the Jacobian? What is the stretching factor? Everything is given. You have to go through all the notes, right? And of course, when we are discussing the question, I'll I'll bring everything here. It's okay that it is already be given, but I'll bring everything here also, right? Okay then. So in the next class we'll continue, and please be there. And in case you had faced any problem, just watch this video, or whatever part you have missed or you are confused about, watch it again. You'll connect it. Fine. Okay then. Thank you everyone, and you are going to attend the next class. That is GA. Fine, at 1. Okay then, happy Dasera everyone. Yes, Lokesh, Kirti, everyone. Okay, bye bye. Bye bye.